Hi everyone, welcome to my computer graphics final projects presentation. Basically, what I've done for this project is consists of two parts: texture mapping and cube mapping, environment mapping, and uh, shadow mapping. So for texture mapping part, texture mapping consists of two parts. First part is to map to a 2D object. And the second part is mapped to a 3D object. So for um, the first part of texture mapping and um, like uses shader, use word shader, just passes coordinates to the fragment shader, and the fragment shader just um, use 60% of the first one and 40% of the second texture. So the first texture, first picture they use first, the pictures I use for the first texture is this Century Tower picture, which is in U of campus near Charlie Hall, and the second picture is the RUF logo. So I use this shader from file, and this this is it's a quad, so obviously. Its quads consists of two triangles. This is indices. So for this text marking part, I used as you can see a index buffer object, the EBO. So um, here's how it look like. So I mapped those two pictures, using those two textures into one 2D object, it's a quad, and this is for the 2D part, and then for 3D part, let me use my code of 3D part and use this use this and use this. So basically, uh, 3D part will be a 3D object that I used that a function called load object, and I wrote up the function when I was doing my assignment 2 and 3. Um, so the function can load a 3D object to the program and use that. So this is a load obj function, and it will like I also have a rotation matrix. Like then I use those buffers and bind them, set up this virtual attribute pointer, and basically just load these two textures. This process are seen for both 2D and 3D version, and use that and pass those texture to the figures, and finally draw this triangle. I add a like interactive function. You can rotate the 3D object based on your mouse input. I can show you right now. As you can see, like yeah, if you put your mouse like in the upper part of the screen, you will rotate in this direction, and you put your mouse in the bottom part of your screen. It will rotate in the opposite direction, and you can see that um, our program has successfully loaded object and mapped those two pictures. And as you can see, this UF uh, logo and the Century Towers picture has been successfully mapped into this 3D object. So there's so much for texture mapping. And then the next part is cube mapping. For cube mapping, basically what I've done is to render a skybox. A skybox. What is amazing, really amazing about skybox is that you can only use the 6 pictures, and it can make you feel like you're in a very large area. So it's a pretty amazing technique. So let me so this is the vertice for the skybox, and the view and projection matrix are also camera position, and all those things I need. And let me what's this? Cube mapping. For cube mapping, also add interactive function. It's based on the your keyboard input. You can rotate the camera's viewing direction. You can press W, S, A, and D to rotate um, the camera into up, down, left, and right. So yeah, I can show you. Oh, I forgot. Sorry. Because when like loading the 2D like the shaders, sorry, the texture in 2D, use this function. It will rotate the picture because when loading the 2D textures, it's like upside down. So I use this function. So that's I'll use this and we'll look for you. So as you can see that um like those kind of weird. Maybe I can change camera's position, you know, into this one, zero, maybe camera position to zero, 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 and the skybox will look very perfect, as you can see. Um, and it's a combination of like cube mapping and texture mapping. Yeah. See um, the texture that we used in text mapping, and it's also the skybox. You can press W, S, E, and D to rotate the camera, and the effects pretty amazing. We can feel that we're actually in the very fast scene, very amazing. And so that's for uh, sorry for cube mapping. Render our skybox. So the next part is environment mapping. For environment mapping, let me use the uh, use this shader. Map this environment, the skybox, and into this object. Okay, so environment is all about shaders. So for the shaders, we'll environment. Sorry, in the fragment shader, as you can see, we use this like this. It's like our viewing direction and then calculate this reflecting direction and use this reflecting directions vector to decide which part of texture that we should use. It's like 3D texture mapping. So we can see like oh, sorry. We can texture map. Oh, sorry. Maybe I use this one, and also I need to change my camera position. Otherwise, it will look very weird. So as we can see, like this environment mapping, we have successfully made map this our like the skybox, so our environment in this head object. As you can see, this the effects pretty amazing. It's like I feel like our objects like is it displays very smoothly. It feels like it's made out of iron or steel, and it looks pretty nice. You can see that, and the scenes like it maps dynamically because when it's rotating, like but the scene is not changing. It's still mapping to the same location, which is this part. So you can see the effect look pretty nice, very realistic. And is for the last part is about the shadow mapping. For shadow mapping, you use two shaders. First one is to generate the shadow maps and store at the shadow maps in your texture, and then use the shadow shader to read this depth value from these shadow maps and generate our shader. So this shadow shader will use a bling font, the bling font illumination model. Um, so because you use a font model and didn't use a font model in the previous shader, so the result will be overwritten. It will be covered by this shadow mapping. Um, so there's a plane. I used this I render a plane so that like the shadow can be projected into this plane and you use this so basically just generate shadow map, use a shadow map to render the shadow. So let me use this. So here's the effect, and as you can see, also yeah, just I also add sorry, um, here here's a sign function over time to like, and then also a translation matrix to make a dynamic scene to make just boxes like moving back and forth horizontally. So as you can see, we have this shadow and look pretty nice. And problem is that we have some aliasing issue with this shadows, but it's looking kind of fine. I can like deal with this aliasing issue in the future. And as you can see, because I use like the shadow bias technique, so that there's no conflicts, no depth fighting on on the object's surface. So it look pretty good. So that's so much for my presentation. Thank you.